Hey everyone, this is Michael Angel, Real Human, and you are watching My Human and Me. So today we're talking about every AI model explained. The AI industry has changed so much to the point where most people can't tell the difference between the chatbot, the model, the company, the actual technology underneath it when it comes to AI, which is exactly why this conversation is getting kind of weird. Most people think ChatGPT is the AI model, and it's not. ChatGPT is the app. GPT is the model family underneath it. And that's the same situation for Gemini, for Claude, for Grok. Different interfaces, different ecosystems, different business strategies. And if that was all foreign to you, then this video is going to help.
Right now, millions of people are basically arguing about which artificial intelligence is the smartest, right? And they are completely missing the fact that within, I don't know, maybe 5 years, standalone AI chatbots probably won't even exist.
Yeah, they really won't.
Yeah.
I mean, it's a completely outdated way to look at it.
Exactly. Like, we're watching the entire tech industry pivot, and the public conversation is just entirely focused on the wrong metrics. You open your feed, and it's just this constant barrage of new acronyms and benchmark scores and startups claiming they've finally solved artificial general intelligence.
Oh yeah, every week there's a new AGI claim. It's exhausting.
It all blurs into this overwhelming noise for you.
Yeah.
But if you actually look at the structural shifts, like the actual hardware being shipped, the developer ecosystems being built, the way models are being, mathematically compressed, a very clear, fundamentally different reality starts to emerge.
Right, and it's so much more interesting than the hype.
So our mission for this deep dive is to map that reality for you. We're bypassing the hype cycles. We want to examine the mechanics of the AI ecosystem as it actually operates today and really separate the underlying compute infrastructure from those glossy, chat interfaces we all interact with.
And that distinction is exactly where we have to start, because if you don't separate the interface from the infrastructure, the entire landscape just looks like this chaotic mess of competing websites rather than, a systematic re-architecting of how software operates.
Right.
The most pervasive conceptual trap right now, and it's one that even seasoned tech journalists fall into constantly, is conflating the application layer with the actual model layer.
Okay, let's unpack this, because it really dictates how we understand this entire space. The classic example, the sort of original sin of AI terminology, is the public's relationship with ChatGPT.
That's the big one.
Most people, if you just stop them on the street, will say ChatGPT is the AI. But, it isn't. ChatGPT is simply a web application. It's literally just a chat interface.
Exactly.
Yeah.
It's just a front end.
The actual intelligence, like the neural network doing the mathematical prediction of the next token, is the GPT model family underneath, like GPT-4, GPT-4, and so on. And that's running on a massive server farm somewhere.
So this matters because most people aren't aware that the branding is hiding the architecture from you. When most people say, I use ChatGPT, what they really mean is I use OpenAI's interface. Underneath that interface is the actual model being used, and that can change constantly. So sometimes you're using a faster model, sometimes a reasoning model. Sometimes they automatically change it to a smaller model because compute demand spikes globally. So that's why sometimes people feel like, wait, why does it feel different? Because the application layer changed, and it may change within your chat. These have multimodal auto switching. So this is the actual application layer changing, not necessarily the intelligence underneath it. This confusion is understandable because the industry benefits from simplifying this language. Saying ChatGPT is much easier to frame. It's easier to market ChatGPT than a dynamically routed multimodal transformer architecture operating across distributed inference infrastructure. Although I'm sure there's an acronym in there. ADRMTAOADII. Okay, never mind. ChatGPT it is. So yeah, that would be a terrible app name. Once you understand this distinction, the entire AI ecosystem suddenly becomes a lot easier to map mentally.
What's fascinating here is I often see this confusion when people complain that an AI has gotten dumber.
Oh, right. ChatGPT feels lazy today.
Yeah, exactly. They'll say, ChatGPT isn't as smart as it was last week. But they're treating the chat window as if it's this monolithic brain. In reality, OpenAI might just be dynamically routing their query to a smaller, faster model during peak hours.
Just to save on compute costs.
Right. Or they might have updated the system prompt that sits invisibly above the user's text. The model itself hasn't, lost its weights or forgotten anything. The application layer has just changed how it interacts with the model layer.
I used to use the analogy of a car to explain this to people. I'd say ChatGPT is the steering wheel and the dashboard, right? The parts you actually touch, while the GPT model is the engine under the hood.
That's a good way to look at it.
You can take that exact same engine and drop it into a totally different car, which is why you see GPT powering completely different software tools via an API. But honestly, even that analogy feels a bit too contained for where we are right now. It implies you still own the car.
Yeah, it's a bit too individualistic. I mean,
yeah.
A more accurate mechanical analogy for an audience that actually follows this space is the electrical grid.
Okay, the electrical grid, I like that.
The GPT model, or Claude, or Gemini, that is the power plant, is generating the raw computational utility. In this case, reasoning and pattern recognition. ChatGPT is just one specific appliance plugged into that grid.
Like a toaster.
Exactly, like a toaster. But you can also plug your CRM software or your coding environment or your automated email marketing system into that exact same grid via API endpoints.
And once you realize you're dealing with a power grid rather than a single appliance, you sort of stop asking irrelevant questions. You stop looking at the news and asking which chatbot is the smartest today.
Right, because that's like asking which power outlet is the smartest.
Exactly. The actual high-stakes competition is about who gets to build and own the underlying infrastructure grid for the next decade of digital life. The companies building these foundational tier models aren't trying to sell you a cute virtual assistant. They are trying to become the operating layer that sits beneath every single piece of software you touch.
Which fundamentally changes how we have to view the map of this ecosystem. A year ago, there was this illusion of a monolithic AI race. It was viewed as this linear track where everyone was just trying to build one single omnipotent model that could do everything perfectly.
The God model.
Right, the God model. But if you look at the deployments over the last several months, the map is completely fragmented. The monolithic model is dead.
Highly fragmented. I mean, once we stop looking at it as just one chatbot, we're looking at a landscape that is split into massive general-purpose cloud models, highly specialized coding architectures, localized models designed to run completely offline on consumer hardware, and distinct systems for image, audio, and video generation.
It's splitting into specialized branches everywhere.
So my question is about the underlying physics of this fragmentation. Why is this happening? Are we splitting these models up because it's just a clever business strategy to sell, specialized enterprise tiers? Or is there a hard computational ceiling preventing us from building one master model that does it all?
It is absolutely a hard computational constraint. It's dictated by the mechanics of optimization and the actual physical limitations of silicon.
Yeah.
You really have to look at how these models consume hardware.
Okay, break that down for us.
Let's take inference. That's the actual process of the model generating a response, as opposed to the training phase. If you have this massive, multi-trillion parameter model that is trained to be world-class at advanced calculus, quantum physics, poetry, and legal analysis.
Very smart model.
Right. But every single time you ask it a simple question like, what time does the grocery store close? You are spinning up a massive amount of computational overhead.
Oh, I see.
The memory bandwidth required to move all those parameters across the GPUs just to generate a trivial response is financially ruinous, and it's incredibly slow.
So it's like using a supercomputer to calculate the tip on a cup of coffee.
Precisely. And this is why the industry has moved heavily toward optimization and architectural tricks. Things like mixture of experts or MOE.
Right, you hear MOE thrown around a lot now.
Instead of one giant dense neural network where every single parameter fires for every prompt, you build a system composed of smaller, highly specialized expert networks.
So one expert handles math, another handles code, another handles casual conversation.
Exactly. And a routing mechanism at the front door basically analyzes your prompt and only wakes up the specific expert needed for that task.
That makes so much sense. That explains the structural fragmentation even within a single company. You want high speed and low latency for a simple customer service bot, so you route it to a smaller, faster expert. You don't want the customer waiting 10 seconds for the model to process pure logical reasoning loops just to, I don't know, process a return label.
Exactly. But it also explains the fragmentation across the entire industry. Different tasks require fundamentally different training data and architectural pipelines.
Sure.
If you want a model that excels at reasoning through complex multi-step logical problems, you have to prioritize slow, methodical deduction in the training phase. That makes it computationally expensive.
But if you want an AI that runs locally on a mobile phone to just summarize text messages, you need aggressive compression.
Right. You optimize for entirely different constraints.
Well, let's dive into the titans of this space, because to understand this fragmented map, we really have to look at the big four general-purpose frontier models. These are the centralized cloud giants.
The power grids.
Exactly, the grids.
So this is the part most public conversations still completely miss. People still think this is which chatbot gives better answers, and that's not the actual competition anymore. The real competition is who becomes the operating layer underneath modern software. And honestly, it's a disturbing jump. Once AI becomes integrated into email, spreadsheets, search, operating systems, coding tools, browsers, workflow automation, the company controlling that layer gains an enormous amount of leverage. You can already see the strategies diverging. So OpenAI wants you inside their ecosystem. Google wants AI to disappear invisibly into tools you already use. Anthropic is heavily targeting enterprise reliability. xAI is targeting real-time cultural relevance. They're not all building the same thing anymore. That's why comparing them purely by benchmark scores is becoming less useful every month.